Under stoichiometry, we will be learning about percentage composition, molecular formula, and empirical formula. Percentage means expressing the quantity against 100. Composition in chemistry means finding out what and all atoms are present in a molecule. Percentage composition means finding out what percentage of each atom is present in a molecule. Normally, we express this percentage composition by mass. To find out the percentage of an element in a molecule, we take the ratio of total weight of element in a molecule divided by molecular weight and multiply this ratio by 100. Let us consider an example. If we consider sulfuric acid, there are hydrogen, sulfur, and oxygen elements in sulfuric acid. If we consider one sulfuric acid molecule, in this we are having two hydrogen atoms, one sulfur atom, and four oxygen atoms. We know that each hydrogen is having its atomic weight 1. So, there are two hydrogen, each of them having atomic weight 1. So, total weight of hydrogen in sulfuric acid is 2. Similarly, there is one sulfur, each sulfur weight 32. So, total weight of sulfur in sulfuric acid is 32. There are 4 oxygen atoms, each weighs 16. So total weight of oxygen in sulfuric acid is 64. If we add up all these weight, we get 98 gram per mole if we consider the molar mass, 98 AMU if we simply consider the mass of one molecule of sulfuric acid. Now to find out the percentage of each element in sulfuric acid, we need to separately calculate 2 divided by 98 multiplied by 100. So percentage composition of hydrogen in sulfuric acid is 2.04. In the same manner, for sulfur, it is 32 divided by 98 multiplied by 100. This is 32.65 percentage. For oxygen, 64 divided by 98 multiplied by 100. This is 65.31 percentage. If we add the percentage compositions of all elements present in a molecule, this should be 100. Molecular formula is the chemical formula which represents the actual number of each atom present in a molecule. If we consider the molecular formula of glucose, that is C6H12O6, this indicates there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms in one molecule of glucose. In the same manner, molecular formula of sulfuric acid is H2SO4. What it indicates is, in one molecule of sulfuric acid, we have 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. Empirical formula is the simplest whole number ratio of different atoms in a molecule. If we consider benzene, whose molecular formula is C6H6, what it indicates is, in one molecule of benzene, we are having 6 carbon atoms and 6 hydrogen atoms. If we divide these numbers by the common factor 6, then we get C1H1 or simply CH. This is nothing but the empirical formula. This indicates for one carbon, there is one hydrogen atom in benzene. Let us consider another example, that is glucose, whose molecular formula is C6H12O6. If we divide these numbers by the common factor 6, then we get C1H2O1 or simply CH2O. This is the empirical formula for glucose. What it indicates is, for one carbon atom, there are 2 hydrogen atoms and 1 oxygen atom in glucose. Generally, we can tell molecular formula is equal to empirical formula repeated n times. This n is nothing but the common factor. If we write it for benzene, molecular formula of benzene is C6H6. Its empirical formula is CH. We have taken 6 as the common factor, so this is 6. To find out the empirical formula, first we need to convert the given data into moles for all atoms separately. Then we need to take the simplest ratio of mole by dividing all moles obtained by the smallest mole. This will become more clear when we take up the illustration. In the third step, we need to convert that simplest ratio, which may be a fraction, into simplest whole number ratio, either by approximating or by multiplying it with a suitable smallest number. It is given that percentage composition of sodium is 29.11, sulfur is 40.51, oxygen is 30.38. These are the gram atomic mass of same elements. If we add the percentage composition of sodium, sulfur and oxygen, this comes out to be 100. With this, we can imagine that 100 gram of the compound is taken, so that percentage composition of each element itself will become its mass in the compound. In the form of table, sodium, sulfur and oxygen are the elements in the compound. Mass of sodium in the compound is 29.11, sulfur is 40.51, oxygen is 30.38. Gram atomic mass of sodium is 23, it is given, sulfur is 32, oxygen is 16. As a first step to find out the empirical formula, we need to convert the given data into moles. For that, we have to divide the given mass by gram atomic mass. 29.11 divided by 23 gives us 1.266 moles. 40.51 divided by 32 gives us 1.266 moles. 30.38 divided by 16 gives us 1.899 mole. Now we have to find out the simplest ratio. For that, we have to choose the smallest of these three numbers, that is 1.266 moles. We have to divide all these three numbers by 1.266 moles. This gives us the ratio 1, 1 and 1.5. This is the simplest ratio, but not the simplest whole number ratio. To convert this ratio into the whole number ratio, either we have to approximate or multiply this number by a smallest number so that all these three numbers will become the whole number. Since it is 1.5, it is not appropriate to approximate this number. Let us multiply all these numbers by 2 so that sodium will become 2, sulfur will become 2, oxygen will become 3. What it means is, for 2 sodium, we have 2 sulfur and 3 oxygen atoms in the compound. So empirical formula will be Na2S2O3. To find out the molecular formula, first we need to find out the empirical formula. After that, to find out the N in this expression, we have to make use of the data given in the problem. Percentage composition is given over here. Along with that, they have given the details about the vapor density of the compound, that is 45. Let us first find out the empirical formula. For that, we need to imagine that 100 gram of the compound is taken so that percentage composition of each element itself will become its mass in the compound. In the form of table, we are having carbon, hydrogen and oxygen in the compound. Mass of carbon in the compound is 26.59, hydrogen is 2.22, oxygen is 71.19. Gram atomic mass of these elements: carbon 12, hydrogen 1, oxygen 16. First we need to convert the given data into mole. For that, we need to divide these numbers by its gram atomic mass. 26.59 divided by 12 gives us 2.22 mole. For hydrogen, it is again 2.22 mole. For oxygen, 71.19 divided by 16 gives us 4.45 mole. To find out the simplest ratio, we have to divide these three numbers by the smallest number, that is 2.22 mole. This gives us 1 for carbon, 1 for hydrogen, 2.004 for oxygen. Now to convert this simplest ratio into simplest whole number ratio, we can use approximate method because 2.004 is approximately equal to 2. So simplest whole number ratio will be 1, 1 and 2. Meaning for one carbon, we are having one hydrogen and two oxygen atoms in the compound. Its empirical formula will be CHO2. After knowing the empirical formula, we need to find out the molecular formula using the expression molecular formula equal to empirical formula repeated n times. To find out this n, we can make use of the expression n equal to molecular weight divided by empirical formula weight. Let us first find out the empirical formula weight. Empirical formula weight will be equal to 12 because there is one carbon, 1 because there is one hydrogen, 16 twice because there are two oxygen atoms in the empirical formula. This comes out to be 45 gram if it is for 1 mole, 45 AMU if it is for 1 CHO2. We can find out the molecular weight by using the vapor density data, that is equal to 2 into vapor density. This comes out to be 90 gram or 90 AMU. Substituting molecular weight and empirical formula weight in this expression gives us 90 divided by 45, that is equal to 2. So molecular formula will be equal to empirical formula n times, meaning CHO2 twice. So the molecular formula will be C2H2O4.